See, we understood that capacitance of a capacitor, the value can be altered by doing something with the space between those material. So one of the materials that we can use between the capacitor's plate are your dielectrics. So what are dielectrics that we understood? Type of dielectrics is what we are trying to understand now. So there are two, polar and non-polar dielectric. We'll look into the difference. First thing first, let's recall the terms dipole, polar, polarization, and non-polar and polar atoms. Okay, we'll need all of them. So dipole is quite simple. We have a charge. We have one more charge. So one is say plus Q, another will be minus Q. They are equal in magnitude, and the difference between their distances, or the distance between them, is not that great. It's quite small. Such a scenario, such a system or setup or charge, pair of charge, is called a dipole. Next, polarization. Quite simple. We have, say, a pair of atoms, a pair of charge or an atom per se. When exposed to an electrical field, it will align in that direction. Okay, at least it may not be exact, but at least try to align in that direction. That process is known as polarization. Non-polarized and polarized atom. So this is an example of non-polarized. Here the example is polarized on the right. So what is the difference? The time the electron spends is such that the net effect is that it has zero difference between the distance or the effective negative and positive charges. While over here, even though the net charge is zero over here, but we can distinguish the negative and positive charge in some sense within the given space, something like dipole. So knowing this, now we'll be able to talk about polar dielectric and non-polar dielectric. So before going to the table over here, let me talk about the diagrams. So first diagram is to do with polar. The second one is to do with non-polar. So this is before and after what? Electrical field. So let's look at the before scenario. In polar dielectric, we can see that atoms are a bit, the atoms are polarized, right? Similar to this. It can be any degree, a lot or a bit, but it's still polarized. In non-polar, the atoms are not polarized. That's a very basic difference. And what else? We'll be looking into the table. So we have three columns. First is your factor, second is your polar dielectric, and non-polar dielectric. So this is the order. So when it comes to permanent dipole moment, it's so in polar dielectric, but not so in non-polar dielectric. That's the very definition. When it comes to polarization, the polar dielectric will get easily polarized, while non-polar will not so easily polarize. Example is water, ammonium, alcohol. Non-polar example is to do with hydrogen, helium, and methane. So this is pretty important. Behavior in electrical field. In polar, when we expose it to an electrical field, please have a look at the diagram. What happens? It will start aligning in the direction of electrical field. It might not directly align in this manner, left and right. It might not align to that degree, but it will start aligning. As in, when we increase the electrical field, what happens? It will get closer and closer to the ideal scenario. While non-polar, it also does this, but here it's a bit more difficult. So molecules in a non-polar dielectric are slightly distorted by the field, creating a weak induced dipole. So that is how you have to present it. So in case of not polar, the molecules rotates. It has to turn to align with the field, creating a strong induced dipole. Overall, the material becomes dipole in both the cases. But in case of polar, the strength of the entire dipole as a whole is a lot stronger than the non-polar. So when it comes to capacitance, when we place a dipole in between two plates, capacitor plates, the capacitance increases significantly. When it comes to non-polar, it increases but not to that extent. Okay. Then loss tangent, this is an extra bit of information. It's about efficiency. Great generates higher loss tangent, so more energy dissipates when it comes to polar. Non-polar, it's not so, it's less. So basically there is loss of energy is higher loss, compared to the other. That's it. Again, I would want to summarize this point. In polar dielectric, the atoms are already polarized. The thing is, they are not aligned. They don't have a general direction per se. When we expose it to an external electrical field, it will start aligning in that direction. That's the basic funda of polar dielectric. When it comes to non-polar dielectric, there is no per se polarized atoms. When you look at it from outside, you might not know if it's positive or negative charge. Of course, technically it's both, but funda here is we are not able to distinguish. So when we expose this to an electrical field, the alignment takes a lot more energy, right? But it will align in the line and all of this, is it not? So this is your direction of electrical field, and you can see the dipoles are aligned to reflect that. Right, there are a few more differences that you guys need to know, and for your exam you need to write. And also few other terminologies that you have to be familiar with.